All right, so let's take a look at this 8.2. Now, the difference between the first lesson, 8.1, and the 8.2 is simply that we have added in the C value. So you're taking what happened when, with the first lesson, all the things that you could do to A and how would it affect the graph, and now we're just adding in one detail more, this C value. Because again, we're building up to this y equals ax squared plus bx plus c. So the only one addition is just the c. What does it do? So I've already kind of preempted us for the parent function because we're going to do a comparison. We want to know, what does the original x squared function, as you see here, how does it get affected if we did something like this, where we added in a 3? So let's go ahead and find the points and plot it by doing the one transformation, this plus 3, and let's see what it does to the overall graph. So here we go. I've got negative 3 squared, which we know is 9, and we add 3 more to it. It gives us 12. That means I can plot the point negative 3, 12. I would go backwards 1, 2, 3, and up to, well, this is 10, so 11, 12. It's going to be just slightly off our graph. It's up there. Next one, we're going to plug in negative 2 for the x, then square it, and then add 3. So negative 2 squared, well, that is 4, and when we add 3 to it, it gives us 7. So we go back 1, 2, but up to 7. So that gets us to, that's 4, 5, 6, 7. It puts us right there. So 5, 6, 7. There we go, right there. Next one. This time we're plugging in negative 1. Negative 1 squared, you know, is 1. Plus 3, that gives us 4. So we're going to go backwards 1 and up to 4. Next one, 0. When we 0 squared plus 3, well, 0 squared is still 0, and plus 3 gives us just 3. So it is 0. We don't go left or right, but we go up to 1, 2, 3. We go up to position 3. Next one, looks like it's a reddish color. We're going to go 1 squared, which is 1, plus 3 is a total of 4. So we're going to go forward 1 and up to 4. So the red one is right there. Next one, this kind of a, I don't know, light green color. I don't know what it is. Anyways, 2 squared. Well, 2 squared is 4 plus 3 is 7. So I'm going to go over to position 2 and up to position 7. And last but not least, 3 plus 3. Oh, hang on. This was supposed to be squared. There we go. Get that on there. 3 squared, which we know is 9. And when we add 3 more to it, that gives us 12. Kind of this lavender color. I don't know what that is. But I got to go forward 1, 2, 3, and up to position 12, which again is off of our graph. But it's the same height as that other brown point. So now we've got this final result, which I will attempt to draw. There we go. Now the question is, what exactly happened between the original parent in black and the new one? Well, at first you might think, well, maybe it got skinnier or something. But let me go ahead and kind of move this graph up. Ooh, that's in 2 pieces. Let me try that again. Up 1, 2, 3. Now those are roughly on top of each other. So really, the graph did not get skinny or wide or in any fashion. Instead, it just moved up. So let's describe that. The transformation was a shift, or you know what? The better word. Let's use the word translate. Translate up 3 units. Now notice Like we said, we counted it up 3 units, one, two, three, which matches the +3 that took place. So somehow this C value is controlling, so far, looks like a movement of the entire graph, not changing its shape, just moving, it's just translating it. Now, I do leave this idea of increasing and decreasing. Where is it increasing? Well, increasing means if we were to, maybe I'm going to zoom in on here. If we were to draw a bike, well, let me draw a bike, and we would typically ride the bike on top. And this is a terrible bike, so don't judge me on my drawing. But we're going to ride a bike. There we go. There's our bike. We would ride the bike not below the line, not underneath it. You don't ride the bike under the ground. You ride it on top of it. So where is it increasing? Well, where do we climb up? Well, rather, that would actually happen here. We would be riding the bike up on this side. So it starts to do its increase, well, from an x position of really 0, and then it goes increasing from then on. So this increasing and decreasing, briefly, we would say that it would go from any value of x that is greater than, well, 0, because it starts at position 0. Now, let me compare this real quick for you. If we were talking about the black graph and the black graph started over here, well, it wouldn't be doing its increasing because it's the same shape. It wouldn't be doing its increasing until we got to position 1, 2, 3, 4, 5, 6, 7. So we would say any value of x that's greater than 7. But because it didn't shift left or right, it starts at that 0 position. What about decreasing? Well, decreasing kind of matches where I rode the bike. Where is it decreasing? Where is it going downhill? Where are you riding the bike down the hill? And it would be everything until you hit, well, I guess this case, the bottom or the vertex position. So it's decreasing. You're riding down the hill from any x value up to, well, position 0. At position 0, I will say this, it's actually on flat ground. And then you start to go back up. Down, flat ground, and back up onto there. So, again, the decreasing would be any x position that is less than that position 0, because that's where we ride the bike down the hill. All right, next one. Another example of this. Just to compare, remember the previous one? It was +3, and the graph shifted up 1, 2, 3. Well, based on that logic, what do you suppose might happen if we have x squared minus 4? What do you suppose what would happen to the graph? Take a moment and think about that. I bet you could have an estimate, a guess as to what would happen based on what happened here when it was +3, x squared +3, and it shifted it up 3. What do you suppose would happen if it was x squared minus 4? Well, let's do the math and plot the points again. So here we go. We're going to go -3 squared minus 4. Well, -3 squared is a +9, and with minus 4, that gives us 5. So I'm going to go backwards to position 1, 2, 3, and now I have to go up to position 5. 1, 2, 3, 4, 5. So I'm only going right there. Next point, we're doing -2 squared, which we know is -2 squared is 4, +4. And when we minus 4, we get, well, 0. So at -2 position, I go backwards, 1, 2, and I have a 0, which means I don't go up or down. I just stay right there. Next one, it is -1 squared. -1 squared is just 1. And when we minus 4 from that, 1 minus 4 is -3. So I go backwards 1, but then go down 1, 2, 3. Oh, hey, my previous point didn't stay, so I have to redraw that one. The previous point was in the color green, so right there. I don't know what happened to it. That was weird. Anyways, next one. 0 squared. Well, 0 squared is still 0, and when we minus 4, that is -4. So 0 means we didn't go left or right, but we go down 1, 2, 3, 4. Next one, in red. 1 squared is 1, and when we minus 4 from it, 1 minus 4 is -3. So I'm going to go forward 1, but down 1, 2, 3. And this next greenish color, I don't know what it is. 2 squared. 2 squared is 4 minus 4. That is also 0. So I'm going to go forward 1, 2, but I don't go up or down, so it's going to plot right there. There we go. And last but not least, 3 squared, which is 9, minus 4, which is 5. And I'll do it in this lavender color. So I'm going to go forward 1, 2, 3, but up 1, 2, 3, 4, 5. So now, what would you say happened? Was your guess right? When we talked about it in the beginning, when we said x squared minus 4, this c value being a minus 4, was your guess correct? Well, what does it look like happened? Again, let's grab the black parent function. Hopefully I grabbed all of it. And it's not getting bigger or smaller in its width, but instead it just kind of slid down. And notice how far it went. 1, 2, 3, 4. So, what was the transformation that took place? Well, again, it was a translation. Translation means a sliding action. So it was a translation. Well, how far did it go? 4, we should say down. It went down 4 units. It translated down 4 units. All right, so the key piece, what does the C do? What does the C do? It simply controls how much it moves up or down. If it's a plus, as we saw, it would move it up. If it was a minus, as we saw in the second example, it would move it down. And how far does it go? Well, it's exactly the number that C is. So I'm going to write this at the top to finish this off and say that C controls up or down translation. Plus up, minus down. The C controls the up or down translation of the entire graph. All right, that is the main piece and the first piece to this idea.